Hello, everyone. You are welcome to today's lesson. Today's lesson is going to be on the topic matrices, just as you have on your screens. Okay, I'm Mr. Hackman, your usual facilitator for additional mathematics. Okay, so quickly, let's go and look at our learning objectives, okay, as far as this particular topic, okay, is concerned. Okay, so learning objectives. As a result of studying this topic, the student will be able to, in general, understand what matrices and its associate, understand, okay, what matrices, okay, I think, okay, understand matrices and its associated concepts. Forgive me, I will do the editing. Okay, and, okay, not end. Define and identify a matrix. So in this case, the first one is the general one. Now we are looking at specific objectives. Okay, know the classification of matrices, know and identify the types of matrices, perform algebra of matrices. So with the algebra, we'll be looking at addition and subtraction of matrices, okay, multiplication of matrix, okay, by a scalar, okay, multiplication of two what matrices. Okay, again, I will do few editing. Okay, these two m's should be small m's. Okay, otherwise I have to make this one a capital A. All right, for uniformity. And last but not the least, find the determinant of a 2 by 2 matrices. All right, so this or these will be our learning objective, okay, as far as this particular topic is concerned. So quickly, let's go and look at what the first information that we need to, or I need to put across. Okay, so now the question is, okay, what is a matrix? What is a matrix? And it's very important. You need to know this. And once you know what a matrix is, okay, you can easily identify such. And therefore, if a question is on matrices, you will know that indeed, okay, this question is on matrices. So whenever a question is given, you'll be able to classify that question to be under this particular topic, okay, matrices. All right, so now let's look at the definition. A matrix is a rectangular array of numbers in rows and columns. So we'll be looking at, okay, numbers arranged in rows and what? And columns. Okay, and the numbers will basically be in terms of what? A rectangle in general. Okay, however, it will be a square as well. Okay, but you should know that a square is a special form of what, right? A rectangle. Every square is a rectangle, and that is very true. But not all rectangles are squares. Okay, so please take notes. Okay, so in this case, okay, let's look at the following. Okay, anytime we talk of matrix, okay, we need to know each of the following, okay, points, okay, for us to be easily or to easily identify matrices. Okay, so let's look at the first one. A matrix is enclosed in extended bracket. So we are talking about extended ordinary bracket, our usual parenthesis, which will be the normal bracket. Okay, this bracket. Okay, but because sometimes, you know, when you write and you are putting it in bracket, the bracket will be too small or will be this small. However, when we are talking of matrices, remember we said it will be a rectangular array of numbers, okay, in either rows, okay, columns, okay, both. So in this case, I'm going to have maybe, let me use A, B, C. I will come down, there may be D, E, F. So because I want my bracket to cover all these, okay, letters that I have here, I have to extend it. So that's why I'm calling it, okay, an extended bracket. I hope my point is well made. So I will make it a little, or we'll make it a little bigger, or a square bracket. And you know a square bracket. Okay, so square bracket will be this kind of bracket. That's what we call square bracket. Okay, other students call it macho bracket. Okay, I don't know why. Okay, but the correct name, okay, is what? Square bracket. Please take note. And a matrix is usually denoted by a capital letter. So matrices are usually represented by capital letters. So unless otherwise stated, if you are labeling your matrix, it should be given, okay, a capital letter label. So please take note. So this matrix that I have here, if I'm labeling it, I'll call it maybe a capital A is equal to, so I'll call this matrix A. Okay, I will give you throw a little more light or more light on, okay, whatever that I need to going forward. Okay, so I'll put everything together, okay, to form our matrix very soon. So the next one will be each item in a matrix is called an element. So anytime I mention element, I mention, okay, entry. Okay, you should know what I'm talking about. So these are some of the key words that you need to be familiar with under this particular topic as well. Then each element or entry is denoted by a lowercase letter with its position written in subscript as row, comma, column, number. So by that, this is what we mean. This particular one, okay, this particular point that we have here, okay, this particular point, usually you see it in foreign books. Okay, however, some of our local, okay, books and textbooks, they are equally adapting. Okay, so I want you to know this, so that if you see it there, you appreciate the concept. So I use A, B, C, D, E, F, okay, for this particular matrix. However, if I have a matrix, let's say B, okay, I can use just a single letter, maybe A, okay, A, just a single letter. But if I maintain the letters as they are here, okay, then it means this entry here should be equal to this entry, should be equal to this entry. So all the entries are the same. Mathematically, that's what it means. But it will not always be so. Okay, the entries will not always be equal. So how do we distinguish, okay, each entry or each element, okay, from the other what element? And by that, we use the subscript. Okay, so if you look at, okay, the letters that we have here, can you see the cursor? Or let me use this. I hope you can see the cursor now.
Yes, please.
Okay, so if you can see that we said rows and column, numbers will be written in rows and column. The numbers will be called entries, okay, or elements, or the letters will be called entries or elements. So if I look at this, I can see how many rows, row 1, row 2. Do you agree?
Yes, please.
Okay, yes. How many column? Column 1, column 2. Do you agree, my professors?
Yes, please.
So you can see that the matrix B, okay, has what? Has 2 rows and 2 columns. However, if you come to the matrix A, how many rows? 1, 2. How many columns? The entire class. How many columns for the matrix A? 3. Okay, so you can see that we are looking at numbers that will be in rows and what? In columns. Okay, however, okay, like let me come back to what I was trying to say here. Okay, so this particular element that you have here, you can see that it is appearing in the first row and the first column. Do you agree? The A that you have here.
Yes, please.
Okay, so this is how we, okay, represent or we indicate what? The sub. So we said the first number in the sub should be for the row. So here we said A is in the first row, and so it will be first row, so 1. Then comma, okay, the second number should be for the column of where your A is. And A, again, you said is in the first column. So it will be 1, 1. Is that clear?
Yes, please.
Okay, yes. So I'm going to do one more for those who are not with me yet. Okay, then later I will ask you to do maybe the next 2. So if I come to this A. Okay, this A is equally in the first column. Let me use this A is in the first column. Sorry, the first row. Do you agree?
Yes.
Okay, it's in the first row. Okay, so obviously the number will be 1, comma. Okay, this A, is it in the first column or second column?
In the
Second column.
It's the second column, so it means to be comma what?
Comma 2.
Comma 2. Very good. Okay, so if that's the case, then the entire class, we are going to do the last 2. Okay, so this particular one, A is in which row? You consider the row first. First row or second row? Row 2. So it would mean we are going to get 2. Are you with me, my professors?
Yes, sir.
Okay, then comma. Then we come to what? The column. A is in which column?
First column.
First column, so column 1, so comma 1. Okay, then let's come to the last A. Okay, which row?
Row.
Second row.
Okay, so it will
Second
be,
row.
give me the sub. The sub, how are we going to write it, the entire class?
2,1.
2, comma
2,
2,2.
2,2. Be very careful. 2,2. So it is in the second row and the second column. Safa.
Yes, please.
Okay, so
Yes.
this is just for the 2 by 2. So if I introduce another A here, you will know that that A will have the sub of what? 1, okay, 3. You get it? If I introduce another A here, it will be 1, 3, because it will be in the first row and what? And the third column. You get it? My professors, are you with me?
Yes, please.
Yes.
Okay,
Yes,
great.
please.
Okay, so that's okay. I think I have extensively explained this particular point. So when you see it in textbooks, you should be able to appreciate that. Okay, sometimes they don't even bring the comma. They will write 1 1, but you should know that the first number is for the row and the second number is for the what? The column. Okay, position of your entry or your element. Now the last one, a very critical information. Okay, the order or size or dimension. So these three, we can use them interchangeably. However, I will be using order. Okay, most often than not, I will be using order. Okay, but if I use size, if I use dimension, you should know that they represent the same thing. Okay, or they mean the same thing. So the order or size or dimension of a matrix is the number of rows and columns. In actual fact, we say the number of rows by the number of what columns. That is a matrix of order m by n has m rows, meaning the number of rows in that matrix will be m, and n columns, meaning the number of columns in that matrix will be what? Will be n. So in the same way, let's come to the first matrix that I have here. Okay, if I want to state the order of this matrix A. Okay, you said how many rows? How many rows here, my professor? 2. So it will be 2 by how many columns?
3.
3. So this is a 2 by 3 matrix. So this matrix A is of order 2 by 3. This matrix A is of size 2 by 3. This matrix A is of dimension 2 by 3. All correct?
Yes, please.
My professors, are you following?
Yes, please.
Yes,
Very
please.
good. Now let's come to the B. The B, how many rows, how many columns? So let's deal with the row first. How many rows?
2.
2 rows.
2. So it will be 2. Okay, by how many columns?
2.
2. So 2 by 2. Okay, so obviously we can say that the dimension, the size, or the order of this matrix B is a 2 by 2. So usually when we are mentioning a matrix, we'll state its order and start mentioning the numbers involved, which will be the elements or the entries. So please take notes. Any questions at this point before I move on to the next slide? Now, professors, any questions?
No, sir.
No, sir. So we are all fine. So far, so very good. We thank God. So now let's look at the next one. Okay, Prof. Martin.
Sir, please, from the 2 by 2, 2 by 3. Is it possible that maybe you multiply them or something?
Oh, no. It's by, you are not looking at its results. Okay,
Yes.
so you cannot say that the order is 6. No. Okay, the order, you know that for us to, if I tell you a matrix has an order, if I tell you 6, okay, 6 it could be 3 by 2, 2. You get it?
Yes, please.
So you wouldn't know how to state your element or indicate your element in the matrix. So if I tell you the matrix is 2 by 2, it means when you are writing the element, okay, you know it will be maybe, let me use a particular example. So if I have a matrix C, okay, and I say that it's of order 2 by 2, and I'm mentioning the numbers, I will say 1, 3. So immediately you get to 3, you cannot proceed because you know it's 2 by 2. So you should have 2 elements, okay, here and 2 elements here down. So maybe 5, 7. Okay, however, if I tell you that the order is 4, okay, how would you get my point? So the order is not in terms of a specific value. Okay, by interpretation, the order is in terms of what? The number of rows, okay, that your matrix will have, and the number of columns, okay, as well.
Yes, please.
As
Thank you,
simple
sir.
as that. So your first number will be for the rows number, and the second number will be for the column number. All correct?
Yes, please. Thank you,
Okay,
sir.
great. You are welcome. Okay, so now let's look at matrix classification. Okay, this one I think I will be very brief on this because most of them I will ask you to read on. I will give you a project work, a group work, a team assignment, okay, to bring out all that I have here. So with this one, in fact, matrices can be classified, okay, under two situations. One, based on the order, and you know the order of a matrix, which is the same as the size, based on the size or based on the dimension. And also based on the elements, okay, or the entries of what? That matrix. Okay, however, when you come to the order, the matrices based on the order, we can look at these types. So you can see the branches, okay, under based on the order. Okay, these types as well. And okay, based on the elements, we have only one special one, which is the null matrix. So remember we did the null vector. Okay, you can also look at a vector to be a matrix anyway. If your vector is written in the column form, let me put it this way. Assuming I have a vector and it is 2, 3. Okay, and I'm seeing this vector as a matrix. What will be the order of this matrix? The entire class.
Please, can you repeat yourself?
Okay, I said this is a vector, is that not it? A vector in the column form. I can say that if I give you A, but you cannot take that A is a vector. Assuming maybe I say OA is a vector, or A tilde is a vector, or AB is a vector. That one you recognize that as a vector. Am I right?
Yes, please.
Okay, so a column vector. Now, if I come and write A is equal to, okay, 2, 3, then it's no longer, it ceases to be a vector. I hope you can see it to be a point. That is fine. But assuming I'm not seeing it as a point, but I want to see it as a vector, sorry, as a matrix, what will be the order of this matrix?
One by one.
one.
One
One by
by one.
one. Let's look at the row. The first row is this. Do you agree?
Yes, please.
The second row is this. Do you agree?
Yes, please.
So how many rows?
2 by 1.
So it will be 2. But your columns will be only 1. So it will be 2 by 1. Do you agree now?
Yes, please.
Okay, so as for the order, we'll do more. So don't worry. Okay, I think I should have given you more there, but I thought you were fine. But I think now, I should believe you are fine. Okay, so let's see. Let me equally, we are dealing with the same thing. Let me equally look at this. So if I have maybe matrix Z is equal to, okay, let me put it this way, then you will tell me the order. Okay, so maybe it is 1, 4, 7, okay, 2, 1, 8, okay, 5, 3, 4. Okay, what will be the order of this matrix?
3 by
3.
3 by 3. So, you know, if you want to count, this is your first row. Okay, second row, third row. So you have 3. Column, first column, second column, third column. So you have by 3. Okay, my professors, I guess everyone is fine now in terms of the order, the size or the dimension of a matrix. How to find it. Are we going forward? I will be using it. Okay, so if your understanding is not perfect, okay, I believe that it should be perfect now. But if it's not perfect, don't worry, because I'll be mentioning, okay, we will be determining, okay, what do you call it? The order of a matrix when we are looking at what the algebra, because the order will matter very much whenever we are dealing with the algebra. Okay, so like I said, I will ask you to read more on this, okay, as your team assignment. These various, they will be considered in terms of what? Of the types of what? Of matrices. So let's go to our next, okay, slide. So just like I said, okay, types of matrices. Okay, types of matrices. And these types of matrices that you have there, okay, like I said, I will give them to you as a team assignment to read, okay, more on that and give me a short note on each of them. Okay, at least I've given you an example under each of them. But how would you be able to, okay, consider or recognize, okay, these were types of what matrices? So I'm not going to say much. I will just mention them, okay, then you will do research on that. Are you okay, my prof?
Yes, please.
Okay, very good. So rectangular matrices, okay, indirectly I've mentioned that. Okay, square matrix, column matrix, row matrix, diagonal matrix, null or zero matrix. I think I was going to talk about that. Then I mentioned vector. Okay, but okay, because of our discussion, I couldn't go back to exactly the point that I wanted to make. Okay, so let me go back. I think indirectly, this one I am helping you quote it because we should know. We said the zero vector will be a vector with all its entries being zero. Is that not it? Its
Yes, please.
components being zero. So a null matrix will be a matrix, okay, with all its entries or element being zero. It's the same thing. I hope you get my point.
Yes, please.
Okay, so you equally check whether a unit matrix will have all its what elements being what being one. Remember the vectors too. Okay, we said if you use the definition for the null, okay, straight away to do that of what of the unit, okay, you will find yourself wanting in terms of the entry values. Okay, so let's see whether this one too will be the same situation. In any case, you are going to read on that. So one of them born indirectly. That's the null, okay, or zero what matrix. Okay, which we said null or zero vector is the same thing. Must we basically use the same language. Okay, so now let's come to, okay, I think I've mentioned identity or unit matrix, singular matrix, scalar matrix, symmetric matrix, then skew symmetric what matrix. So you read on all this. I'll put it on the platform. Okay, but before you see it on the platform, you know, okay, as serious students, please read on that. You can make your personal notes on that. When you meet as a team, then you discuss, you add and you subtract so that you don't waste time on that. Okay, so thanks for your understanding and cooperation. So now let's move on to, so this one too, I think it will come as an assignment. You need to know the type very well before you can indicate. Okay, so the types, I'm going to give that one to you fully as an assignment, team assignment. Okay, so take note. Now, let's go and look at equality of matrices, a very important concept under matrices. Okay, so take note, two matrices are equal if they have the same order. So underline that's very critical. Now you know what we mean by the order of a matrix. So I won't belabor the point there. Okay, now let's look at then also corresponding entries. Okay, they should have the same order, then corresponding entries, okay, must be the same. So these two conditions, okay, must be satisfied before you can say that your matrices, okay, that you have there are equal. So please take note. Now, professors, are you with me?
Yes, sir.
Okay,
Yes.
very good. Okay, so let me see. Okay, so like I said, okay, for your matrices to be equal, first of all, they should have the same order. If the order not the same, the matrices that you want to determine or you want to say that they are equal, if the order not the same, automatically the second one will not kick in. You can say that, okay, the matrices cannot be equal and are not equal. Okay, however, if they have the same order, then the second condition will come in. Corresponding entries must be the same before you can say that they are equal. Just like vectors, for two vectors to be equal, corresponding components must be the same. You get the point?
Yes, please.
Okay, very good. So that is given that a vector A, did I say a vector? Forgive me. The matrix A is equal to A, B, C, D. So this matrix is of order
2 by 2.
2 by 2. Very good. Okay, so 2 by 2 matrix. Okay, so this is a 2 by 2 matrix. And matrix B, E, F, G, H. Okay, so I'm using these letters, okay, for their entries. So what is the order of this matrix?
2 by
2
2.
by 2.
2 by 2. Very good. Okay, so once they are 2 by 2, then it means most likely they could be equal. They could be equal based on a certain condition. So with these two matrices A and B, for matrix A to be equal to matrix B, i.e., this matrix A should be equal to matrix B. Okay, then your entries, corresponding entries must be the same. Corresponding elements must be the same. So your first element here or entry must be equal to the first element here entry. So A must be equal to E. Second element must be equal to second element, or second entry must be equal to second entry. So B must be equal to F. Third must be equal to third. So C must be equal to D. Did I say C must be equal to J? And or D must be equal to H. Is my point well made?
Yes, please.
That's the only situation that what your vectors, okay, could be okay equal or could be regarded to be equal vectors. Equal matrices. Why am I saying vectors? All right, okay, forgive me. Okay, so now let's look at how best we can make use of this information, that equality of what of matrices in dealing with the question or the worked examples here. At least I will be well convinced, okay, that you are indeed following. So let's see. State with the necessary conditions whether the following pairs of matrices are equal or not. Okay, so as usual, so these are the matrices. The first A, the pair, B, another pair, okay, up to what? Up to D. Okay, so as usual, the first thing that you write is solution. Do you have any major question number? No. Do you have, okay, anything to understand? Yes, we are supposed to state with necessary condition. So condition must be attached. Okay, if you say that they are equal or not. So necessary condition, we have to state the condition. Okay, then after that, what do? You come to A. There's nothing that we can extract here. So you come to the sub question number A. Then we extract all that we are given here. So given the matrix A, okay, 1x, y minus 2. And the matrix B, 1, 4, 0, negative 2. Okay, so please take note, this is not 0 minus 2. Okay, it is 0, negative 2. The negative, okay, let me, okay, write it. Well, I think you get it. So I've made my point. The negative is attached to that particular entry or element. So now let's see. What is the order of the first matrix? The A. My professors, what's the order?
This is a 2 by
A 2 by 2. What about the B?
2 by 2.
2 by 2.
A 2 by 2. So it means it could be what equal. They could be equal. These two matrices could be equal. But what's the condition for them to be equal? And the condition is that for A to be equal to B. Okay, let's see. The first entries of are the same of A and B. First entry here 1, 1. Okay, so for them to be equal, corresponding entries must be the same. So X, the entry for X here is the second one. X must be equal to the entry here, which is 4. Do you agree?
Yes, please.
Yes.
Okay, and Y must be equal to the entry here, which is what? 0. Okay, the fourth entries are the same. So you know that the first and fourth entries are the same. Okay, but your third and what? The second and third are the unknowns. So the unknowns here, okay, will tell us what's, okay, we need to put there for what do the matrix here, the entries here to be equal. So you equate, okay, the corresponding ones, you equate. So X will be equal to 4 and Y will be equal to 0. That's the only situation where, okay, these two matrices A and B will be equal. Point well made, my professors.
Yes, please.
Okay, so now, if that's the case, let's look at the B together. So B, okay, B, what are we giving? So we are going to extract. Okay, only that I will not extract else. I will use this, you will extract, just to save time. Is that clear?
Yes, please.
But you cannot do this. Please take notes in your, okay, exams or what have you. So now we are saying that for which matrix? We are saying the matrices are C and D. So for matrix C to be equal to matrix D, okay, what is the condition? So now let's see whether it will be possible. 2 by 2. Okay, so this is a 2 by 2 matrix, a 2 by 2 matrix. Now let's look at the entries. Okay, second entry same, third entry same, fourth entry same. So it means for them to be equal, the first entries must also be the same. But the first entry here is 1, this is Q. So for them to be the same, it means Q must be equal to 1. Do you agree?
Yes, please.
Okay, so in this case, what are we going to write? We write, okay, Q should be equal
It's
to what?
equal to
1.
1.
Or 1 must be equal to Q. It's the same thing. That's the only situation that they could be equal. How far, my professors?
Yes, please.
Okay, very good. So now let's look at that of the C. Okay, together. Okay, so C2 we have to extract. And remember, if you are moving from A to B, you leave a line. One sub question to the next sub question, you leave a line. Okay, so then B to C, you leave a line. So given, what are we giving? Equally, you come and extract your E and F. Is that clear?
Yes, please.
Okay, so once that is extracted, okay, then what do? You come and check. Okay, what is the order of this matrix? The first matrix, my professors.
2
The
by
2 by
2.
2 matrix.
Okay, so 2 by 2, very good. You are doing well. Okay, what is the order of the second matrix?
2 by 3.
So 2 by 3.
2 by 3, very good. Okay, now you people are order experts. Okay, so is there a possibility for these two matrices to be equal?
No, please.
So why?
Because
Because
the order is not the same.
the order
Okay,
in
very
is
good. As simple
yes.
as that. So if the order not the same, you cannot talk about what the entries. Once the order not the same, it's sufficient for you to say that the matrix cannot be what? Equal. So in this case, I will say that, okay, matrix A. Oh, so did I say it was, what are the names? E and F, right? I got it wrong.
Yes.
So not A. So let me go and take my eraser and clear that. Okay. So we are going to guess. I will say that E, okay, is not equal to what? Matrix F. Okay, and here, if you want to attach your reason, you attach. Okay, all right. So since, okay, they don't have the same order. Oh, oops. Since they are, or they don't have, like I said, don't have, okay, the same order. Safa.
Yes, please.
Okay, so now the last one. Okay, so think through. Let me see if, okay, I'm recording. Okay, so I resume recording. So under what situation can we say that the matrix M will be equal to the matrix N?
If the entries in M is equal to the entries in N.
Therefore,
X is equal to 4, comma, Y is equal to 2, comma, Z is equal to 5.
okay, very good. Please, do you all agree, my professors?
Yes, please.
Okay, very good. So I'm not going to write that one. Let me see if I can play on your smartness. Okay, so let's see. Assuming I have a vector, did I say a vector matrix? Okay, A. All right, so to be, okay, so 2, okay, 3, okay, 2, let me say 4. A matrix B to be equal to, okay, 2, X, okay, Y, okay, 3. Let's see. All right. And what situation will the matrix, the two matrices be equal? Okay, as for Prof. Carol, you just answered. Okay, well, so let me see if I can call another person.
If they have the same.
Okay, Prof. Martin, let's go.
Okay, sir, please, for the two matrices to be equal, X should be equal to 3 and Y should be equal to 2.
Okay, so that is Prof. Martin's, okay, answer. Any other?
So please have my answer.
Okay, hey, Prof. Gideon.
So please, for A and B to be equal, X must be equal to 2 and Y must be equal to 4.
X must be equal to 2.
X must be equal to 2 and Y must be equal to 4.
X must be equal to 2, Y must be equal to 4. Okay, that's your answer. Any other? Let me see the other. Okay, Prof. Genius. At this point, I don't read charts. Okay, you put up your hand. Okay, I've told you. If I want you to give you your answers by the chat, I will tell you. Yeah. I called another student. Serious.
was a mistake.
Your hand is up. It was a mistake.
Yes, sir.
You can't be serious. But even if it's a mistake, I've called you. You should be able to answer this question. God wants you to answer. That's why He made you do that mistake.
So it can't be equal.
Why? Why?
So I can't properly explain.
Oh, it should be. It should be. Because I've given you the condition. So just use the condition. That's all. I want Prof Genius to nail it.
Yes, please.
So Prof Genius, you still have the floor. Because I know it wasn't by instinct. Something informed that decision for you to say that, okay, they cannot be equal. So just give me what came to mind that you used.
Okay, so I didn't see the question well.
Okay, so now.
So x is equal to 3. Y is equal to 2.
What's the answer? You started very well. Okay, Prof. Caroline. No, I think, Carol, I've given you today, you have spoken a lot. So please permit me, let me give other students for the chance. Okay, Prof. Be nice.
Yes,
Dennis.
Yes. So please, they can't be equal because even though their order is the same, but the arrangement of the numbers is different.
Okay, very good. Okay, so please, this is it. So don't be, that's why I said, let me play on your intelligence. First of all, check. You can see that this is 2. Okay, this is 2, the same. Okay, for it to be equal, okay, you said x must be equal to 3. So that is it. The y must be equal to 2. But also, the last entries here must be the same. So because the last entries here are not the same, whether if x is equal to 3 and y is equal to 2, there is no way they will be the same. Do you get the point, my professors?
Yes, please.
Okay,
Yes,
so my point is always check the knowns. Okay, the ones that you know, check all of them, whether they are the same. If all your knowns correspondingly, they are the same, then you go to the variables. And it means the variables correspondingly must equally be the same to the known. You get the point?
Yes, please.
Okay, so take note. Okay, so some of you, in fact, as numbers of I can say without fear that most of you would have gotten it wrong because you just went straight away to what we were giving. So you fall victim. So take note of that. Okay, so the next time you see questions like this, if anyone gets it wrong, I will come to your various houses and give you, okay, a big knock. All right. Okay, so let's see. Are we fine up to this point, my professors? You are doing well. Keep it up. Are we fine?
Yes, please.
Okay, great. Prof. Carol, is it that you've done matrices?
So please,
Yes. I know it's yes.
Yes.
You've done it right.
Yes, please.
So that's why you are on fire like that. All right, I like that. Okay, it's good to make your teachers proud. So let's move on to the next slide, if you are all fine. Okay, so now we are going to look at the algebra of matrices. The algebra of matrices. So the algebra, first of all, we'll look at addition and subtraction. Usually they move together. Okay, so quickly, okay, the first one, addition and subtraction of matrices. If a matrix A of order 2 by 2 and matrix B of order, okay, this, okay, then the matrix A plus the matrix B will be equal to this matrix A plus this matrix B. Basically, this is all that you need to do. The information is stated here. To add or subtract matrices, we add or subtract corresponding entries. So just like vectors, okay, if you want to add vectors when they are in the column form, okay, we know we add corresponding components. So with this one, the entries are not called components. I mean, the numbers, they are called entries. Okay, Prof. Martin.
Sir, please, what if the order is not the same?
Okay, so that was what I was going to say. Okay, anyway, you wanted to take the wind out of my sail. Okay, so this is it. First of all, for you to talk about addition being possible, you know, when we are dealing with algebraic expression maths, okay, before you can add and subtract, you should have, okay, your terms to be alike. Do you agree?
Yes, please.
Okay, in the same way, for you to add and subtract matrices, your matrices should be alike. And when we say matrices are alike, it means they have the same order. So before you can add and subtract matrices, they should have the same order. I hope it's my point well made.
Yes, please.
Yes,
If the order not the same, you cannot add. You can't take about combining them with addition or in terms of subtraction. So in this case, matrix A plus matrix B will be equal to, we said we add corresponding, okay, entries. So A plus E will give you the first entry, B plus F will give us our second entry, C plus G will give us our third entry, then D plus H will give us our fourth entry. Well made.
Yes, please.
Yes.
Okay, then the same for the subtraction. You subtract corresponding entries. So it will be A minus E, okay, then B plus minus F, C minus J, then D minus H. That's exactly what you have here. So because you are adding and you are subtracting matrices of the same order, if you add and subtract, the result will equally be, okay, of the order that your matrices that you added came. So if the matrix here 2 by 2, this is also 2 by 2. If I'm able to add, my result will also give me a 2 by 2 matrix. Point well made.
Yes, please.
In the same
Yes,
way, if you are
please.
able to subtract, it will still give you, okay, a 2 by 2 what matrix, the same order. Okay, so if that's the case, now let's come to real, okay, example. Okay, the real deal. Okay, so I have, okay, the solution already provided for, okay, the one that we are going to work, okay, with or work on together, okay, just to save time. So I will just walk you through the solution. Okay, if I move fast at the expense of your understanding, as usual, don't hesitate to let me know. Now, professors, is everyone on board? Have I left anyone behind? If you have left yourself behind too, please let me know. Are we all fine?
Yes, please.
Yes, please.
Yes, sir.
Okay, great. All right. Okay, so, oops. Okay, so I didn't forward, I just realized I didn't forward the attendance at that particular time. Okay, in fact, my attention, okay, so don't worry. I'll capture another one at the end. Okay, so that was at that time. Okay, so please, this is it. As usual, let's read the question. We'll be giving, okay, matrices. How many of them? 1, 2, 3, 4, 5. 5 matrices. Okay, I mean different matrices. Okay, we are asked to find I. Okay, please, I've told you if you are here, okay, avoid using the, what do you call it, the chat, unless your audio is not okay. Okay, all right. Augustine, well noted, okay, or your environment is noisy. Okay, so if you can put up your hand, Augustine. So if you put up your hand, I won't ask you to. Once I know that you are the one, I will go and look at the chats. Then maybe I will see your answers there or your questions, your contributions equally there. All right. So that in real time, I will be able to factor all your concerns. So now let's go. Given you extract, now we come to I. We are asked to find the matrix A plus the matrix B. So I have therefore A plus B will be equal to, what is your matrix A? You come and write it. Plus your matrix B, you write it as well. You indicate that. Okay, so you know, with this one, you know, when you are combining, you combine mentally. So if I'm adding this matrix and this matrix, okay, addition is possible because they have the same order. So if I'm adding, I add corresponding entry. So that will give me 2 plus 5, which is 7 for my first entry, minus 1 plus 4, which will give me 3, minus 3 plus minus 1, which will give me minus 4, then 4 plus minus 7, which will give me minus 3. So that will be my final result of the matrix A plus B. All correct?
Yes, please.
Yes,
Okay, so when
please.
you are adding, you add mentally. So don't come and write 2 plus 5, okay, minus 1 plus 4. No, do that mentally. Just as when you are adding 2x plus 5x, okay, you write that straight away as what? 7x. You don't write 2 plus 5 in bracket x before you come to 7x because you are matured. Addition, subtraction can always be done mentally. Okay, so now the matrix B plus the matrix A. So this time around, the matrix B, you write that one first plus the matrix A. So after that, because they have the same order, we can add. So when we are adding, we add corresponding entries. So 5 plus 7, which is 5 plus 2, forgive me, which is 7. Okay, 4 plus minus 1, which is what? 3. Minus 1 plus what? Minus 3, which is what? Minus 4. Minus 7 plus 4, which is minus 3. So that will give us the result here. All correct, my professors?
Yes, please.
Yes,
Okay.
please.
All right. Okay. So today we started a new topic. So no one can tell me that because you didn't start with us, okay, you are struggling. Okay. We started the journey, the entire journey together. Okay. Unless maybe you joined late. But even, okay, apart, I mean, with that, based on the explanation that I've given so far, you should be able to, okay, come on board. So now let's look at vein. Okay. So vein, what are we supposed to find? This is vein. Okay, A plus B plus what C, A plus B in bracket plus C. Okay, so this is it. So this will be equal to, here, this is what I did. Because I have done A plus B, okay, I inferred. Remember, I've told you you can do that. But that one comes with a risk, and you know the risk. If this is wrong, what you are inferring from is wrong, you are doomed. So you have to be very careful. Okay, otherwise, then it means you were supposed to come and write the whole of this in square brackets. So it will be this matrix plus this matrix, that's your A plus B, then you put it in a bigger bracket or a square bracket. That will be for the first 2 terms here in bracket. Then plus what's this? Then you come and do the one in bracket first, which will end up giving you this, which we inferred. Then you indicate this one, then you move to this one. But once you have done it in the same question, okay, it is better to infer. Okay, so now the second one, you see that, okay, exactly the point that I was trying to make here, assuming you haven't done it, okay, will be catered for in the VI example. So again, what are you asked to find? You are asked to find this. So I can write therefore, this is what I have been asked to find. This is an expression, so each step on the way, I use equal to. If what I'm dealing with is what, an inequality and equation, then I start with implication. I'm saying this because we have new students on board. Okay, Prof. Joel.
Sir, please, so it means that addition of two matrices are commutative.
Hey, Joel, you always want to take mine. Don't worry. Okay, so very soon. Have you done matrices?
Yes, please.
Hey, so you want to flex the muscles. I like that. Okay, don't worry. That question will be answered very soon. Okay, thanks for that contribution anyway. All right, so this is it. So that is what we have here. So now with this one, you just extract. We can conclude with this straight away. So per experience, it will be there for. Other than that, later when you are combining to get your final answer, then you come and write there for whatever that you were asked to find is equal to your result. So in this case, you state your A, okay, plus your B plus C. You know, the B and the C, they will all have brackets. So you put that one in a square bracket or a bigger ordinary bracket. And you know that you have to, board mass, you have to deal with what you have in brackets first. So you come and combine this. So this will be 5 plus 1, which is 6, 4 plus 3, which is 7, minus 1 plus 5, which is 4, minus 7 plus 8, which will give us 1. My professors, are you there?
Yes, please.
Okay, so now we've gone back to the way you were dealing with. So one, okay, simple matrix, another simple matrix we are adding. So we add corresponding entries again. So it will be this plus that will give us 8, minus 1 plus 7, which will give us 6, minus 3 plus 4, which will give us 1, then 4 plus 1, which will give us 5. Okay, so that will be it for whatever that we have here. So that's it for what we have here. Now, the conclusion is that, I mean, look at the second part of the question. What conclusion can you draw about your result in, okay, alpha, I and II, then beta, V and VI. So your result in I and II, then V and VI. So if you compare, obviously, A plus B, this gave you the result. When we swap the matrix A and the B, okay, B plus A, we had the same result. So in this case, like Prof. Joel said, we can confidently say that matrix addition is what? Commutative. My professor, do you agree?
Yes, please.
Okay, very good. Then if you come here, you can see that obviously you have three, okay, letters, okay, with two operations, but they are the same operation, identical. Grouped. First two grouped results, last two grouped results. So obviously this cannot talk about commutativity because commutativity will deal with only two elements. Okay, however, here we have three. So associativity all the way. So the result here is equal to the result here. So again, you can equally say that matrix what addition is what associative. Is that clear?
That's good.
Our
Yes,
addition of
please.
matrices is associative. So this takes us into our next slide, which will answer the conclusion. Okay, so alpha, therefore, matrix addition is commutative. Beta, therefore, matrix addition is what? Associative. All correct, my professors.
Yes, please.
Okay,
Yes,
so now let's see. Okay, what's all right. So we should be able to deal with at least a scalar and what and a vector. So a scalar and a matrix. So let's come and deal with the subtraction first. Okay, then we see if time will allow us to look at our next concept. Okay, so again, the same concept. Okay, the same stuff. So let's see the same information, only that this time I changed. Okay, the A minus B, originally it was A plus B, so the same question. Basically, I just changed. I'm talking about the matrices the same, but the questions here are different. Okay, so 2, given you extract all your matrices, okay, then I, therefore A, matrix A minus matrix B, you state your matrix A, then minus you state your matrix B. Then you know, for you to subtract two matrices, we subtract corresponding entries. So that will give us 2 minus 5, which will give us minus 3, 2 minus 4, which will give us minus what? 5. Okay, there, sorry, did I say 2 minus 4? Minus 1 minus 4, which will give us minus 5. Then minus 3 minus 1. So it will be minus 3 plus 1, which will give us minus 2. Then 4 minus was 7, which will be 4 plus 7, which will give us 11. All correct, my professors?
Yes, please.
Okay, then you come and do II. So II too, you should be able to do it. Okay, and that will give us exactly what we have here. So if you compare, obviously A minus B is not equal to B minus A. So the operation here is for subtraction. Therefore, we can say that matrix subtraction is not commutative. You get a point?
Yes, please.
Okay, so you later try, okay, the V and the VI. Okay, and you draw your conclusion for the beta. Point well noted, my professors. You try it on your own.
yes, please.
Okay. Is everyone fine? If you don't do it, I believe you will be fine. You can try it on your own.
Yes, please.
Nonetheless, if you still want us, some of you want us to do it, no issues. Only that if you think doing it will not be necessary, you understand, let's move forward and cover more. All right, okay, so we thank God you are all fine. So on that note, okay, this will be for the continuation of what we have there, which I ended there. So now let's look at multiplying a scalar and a matrix. So you can see the concept basically in terms of the algebra is the same as for the vectors. Okay, the vectors too, we looked at addition and subtraction of vectors, multiplying a vector by what? By a scalar, then we did multiplication of what? No, we didn't do multiplication of two vectors. Okay, that one, we didn't do that. That one, you do it later in form 2. So take notes. Okay, Prof. Angie.
Also,
you are watching.
Hey, Prof. Asada, you've been exposed. Thank you, mommy. All right. Okay. So, Prof. Angie, you have the floor.
So please, since you said multiplying a scalar by a matrix, does that mean that matrices are vectors?
Okay. So let me mute. Let me mute. Okay.
Come and hang it on the line here.
Okay, all right. So Angie, come again.
So please, I was saying, since you said multiplying we are talking about multiplying a scalar and a matrix. Does that mean that a matrix is a vector, like it has both
Oh,
magnitude and
no.
dimension?
That's why I said you can consider a vector as a matrix. Okay, but you cannot consider a matrix as a vector. If some of the matrices you can consider that as what? Not all matrices will be considered. In fact, the two they are distinct. Only that because I mentioned column and rows. Okay, that's the more reason why I try to connect them. I hope you get my point.
Yes, please.
Otherwise, the two they are distinct. They are different things altogether. Take note of that. Okay, so here we'll be looking at multiplying a scalar and a matrix. And you know that when you talk of a scalar, we are talking of a matrix is a matrix. A matrix, you know the form. Okay, a scalar will just be a number, a particular number, a constant. Do you get the point? Okay, so exactly what I've stated here. If K is a scalar and A is a matrix, and here I went for a 2 by 2 matrix, it works for any matrix of any order. Then the scalar K times the matrix A will be equal to K times this your matrix. So just like a vector situation, you multiply each of the components by your scalar. With this one, you multiply each of the entries by your scalar. So it will be K times A, which is be AK or KA. K times B, K times C, K times D. And that will give us the result that we have here. All correct, my professors?
Yes, please.
Okay, so it means, illustrative example. So it means if I have, two times a matrix, which has the entries -1, 3, 4, maybe -2. This will be equal to, I multiply each of the entries here by the scalar 2. So it will be 2 times -1, which will give me -2. 2 times -3, which will give me 6. 2 times 4, which will give me 8. Then 2 times -2, which will give me -4. It's a matrix, so I put it in my extended bracket or my square bracket. All correct, my professors?
Yes, please.
Okay, so we are going to do more. Don't worry. We have more examples here. So that was just an illustrative example. Okay, so let's see. Given that X is equal to the matrix X, the matrix Y, and the matrix Z with their corresponding entries, find the following. Okay, A, 2X, so 2 times the matrix X. B, so you can see the questions, all this. So now, what do? We extract. So given, A, therefore, 2 times the matrix S will be equal to 2. What's your matrix S? You come and put it there. So now you know you have to multiply each of the entries, or elements in the matrix by your scalar. So 2 times this, which will give us 2 times -1, -2, 2 times -3, -6, 2 times 5, what's 10. So that will give you your final answer. Therefore, this time our scalar is negative. The same thing. Each of the entries by the scalar. So this multiplying each of them will give us what we have here. Alpha, my professors. Hello,
Yes,
my
Master.
professors.
Yes,
Should I go over or we are all fine?
No, go over.
Okay, Carol. All right. So you are multiplying which one, the A or B or both?
Please, a B.
The B. Okay, so minus. Minus 3x. So minus 3 times your matrix X. This is your matrix X. Is that not it?
Yes, please.
Okay, so let's see. So it will be minus 3 times 3, and that will give you -9. Minus 3 times -1, that will give us what? 3. Minus 3 times -3, that will give us +9. Then minus 3 times 5, that will give us -15. Do you get it now?
Yes, please.
Okay, Prof. Angie.
Please, I wanted to ask that if the question looks like this, they've already written that given that X is equal to this, do we still need to extract it in our solution?
Okay, so remember the idea, the concept, okay, is that anytime, the advice is anytime you are given any question, there will be information that you need in the question, and that's the information that you extract, okay, in your preamble before you come and do so that, okay, if maybe your question paper falls or what have you, at least once you have that information there, you can rely on it. Okay, that's not the idea. The question is, I always tell my students, if I sell you to the market, I send you, sorry, okay, to the market of on an errand, okay, to the market, okay, I give you money. Obviously, you cannot go, okay, to the market without the money. So the first thing that you do is to pick the money. Is that not it? So that will be your extraction. After picking the money, then after that, you go to the market, buy all the stuff. So that will be your method. When you come, you bring the stuff, will you just go and deposit it there? Definitely you have to come and tell me that, okay, maybe mommy, daddy, I have, okay, brought the stuff. So that will be your conclusion. Is that clear?
Yes, please.
So that's how I usually, okay, state it. Extract the information needed, okay, proceed. That's go and buy the stuff, okay, then you draw your conclusion. So always extract a method, conclusion. Extraction, method, conclusion. Giving, method, conclusion. Is that clear?
Yes, please.
Okay. However, with this one, okay, if you don't extract, no issues. But sometimes, okay, we give marks for the extraction. That's why usually I say that the extraction should always be a bonus mark. Whatever you be given, just copy and paste. Because some of them you extract directly, and some, okay, you have to change the English to math. So you extract it mathematically. And that one usually, okay, we give marks because we want to see how best you can extract. So my point is, okay, always extract. Point well made.
Yes, please.
When you are extracting and the roads giving that, don't write the that, just write the giving. Then extract what you have there. It connotes the same meaning. Afa.
Yes, please.
Okay, great. Okay, so on this note, okay, this time round, okay, with the D. Okay, if you're able to do the D, you should be able to do the C and the E. So let's do the D. The D, okay, our scalar is not pretty, a fraction. Apart from that, it's also negative. But don't worry, you know that you have to multiply each of what the entries by this scalar, which is not pretty. So you can work with this scalar, whether it is pretty or not, you can work with it. So this means it will be minus 1 over 6 times 15, minus 1 over 6 times negative 3, minus 1 over 6 times what? Negative 9, then minus 1 over 6 times 6. And that will, so if you do that, once you do that, you know that this will be the same as minus 1 times 15, then over 6. And then minus times minus will give you 3. So it will be 3 over 6. Then this will give you minus times minus. So minus 1 times minus 9, that is minus positive 9 over 6. So that will give us this. Okay, then it will be minus 1 times 6. That will give us what? Minus 6 over what? 6. But you cannot end here because the fractions, any of them that you can reduce, you reduce. So you go and reduce each of the fractions and that will give us what we have here. Point one made. Okay, Prof. Gideon. Hello, Prof. Gideon.
So basically, the fractions you have there to meet. So basically, the fractions there to meet fraction.
Can you change I can say that yes. Remember when we were doing vectors 2, I told you when it comes to vectors and even points, what have you? Okay, if you fail to do your change here, okay, to corresponding mixed numbers, it wouldn't be an issue because what you have there, the fraction here is not the only fraction that is there. That if your fraction that you have there is the only fraction that you are concluding with. Okay, let's say I solved for s and I had s to be equal to maybe 3 on 2. This is what I'm concluding with. I cannot conclude with what? An improper fraction. So I change it to mixed numbers unless otherwise stated. So with this one, you can change for consistency's sake. However, like I said, special situation, if you don't change because there are other values out there, if you don't change, no issues. Okay, that's why we say for every rule there is an exception. You get a point.
Yes, sir.
Okay, but for consistency's sake, if you want to change, you can change. Okay, as simple as that. Point well made, my professors. Okay, Prof. Carol.
Mr. Akman, please, the final answer, like the D, the answer you got there, please, the -5/3. Is it -5/3 or -5/2?
Hey, let me check. Okay, so no, it's supposed to be 2. Thank you very much. Okay, 3 will go here, 2, and go here. So it's supposed to be 2. Okay, so please take notes. Okay, let's do the correction. Is it clear now?
Yes, please.
Okay, so that was a nice way to correct what you have there. All right, so thank you very much. Okay, so I guess we are all fine at this point.
Yes, please.
Okay, so on this note, okay, this will take us to algebra of matrices, the last aspect of algebra, which will be matrix times a matrix, and that is a little technical. Okay, so I'm going to shelve that one, okay, and we'll look at that in our next lesson. We'll look at the matrices, multiplication, then we come to finding the determinants of a 2x2. Then we are done with matrix. Unfortunately, okay, I couldn't, okay, end the entire lesson on matrices, okay, today. We have to meet, okay, extra. If it becomes necessary for me to, forgive me, okay, give you the continuation record and send it to you, I will do so. Otherwise, as for this one, it's technical, so I don't think it will be ideal. So I want us to meet maybe 30 minutes or so. Okay, I'll walk you through the multiplication. Once you are fine with the multiplication, that will be it. You will have no issues with what? With matrices. Now, professors, are you there?
Yes, please.
Okay,
Yes,
so
please.
great. So, okay, this is where we are going to end. So we are going to end with the algebra on the addition, subtraction, and the scalar and what, and the matrix multiplication. So this is all that, okay, the time will allow us to do today. Okay, the remaining 7 or so minutes, if I touch that, wouldn't be able to finish. Okay, so on this note, okay, please don't leave. I would want to say thank you very much for your time and for your attention. Okay, may the good Lord continue to bless us all.